So today the idea we're going to work on is graphing horizontal and vertical asymptotes. And this is like we're creating a framework. If you guys have ever taken any type of animation class, you always draw these little lines to give you like an idea of where your face should go, right? And I'm Batman, right? Okay, but what we're doing, we're creating a framework, a structure where we can graph our rational functions. Rational functions are fraction functions. And these fraction functions have a problem with them, have a big problem. The big problem is that you end up dividing by 0. So let's give ourselves this example. Example is 1 over x squared minus 4, which can be factored to be 1 over x plus 2, x minus 2. Okay, probably a problem that we've seen before. And we're asked to graph this function. And we could start just plugging numbers. We could create a t-table, right, and start plugging numbers all day long. But that's not our goal. We want to look for special characteristics about this graph that we could then set up a framework to graph around. We did this for large order polynomials. If you remember when we're graphing large order polynomials like x cubed, if I could tell you the roots were 1, let's say 2, and 3, we could say the roots are 1, 2, and 3, and then we had a way of going about it to graph the points out. If these are my roots, what's the end behavior on the right? What's the end behavior on the left? And we don't have to worry about what's going on in the middle as much. We just had to worry about our checkpoints to get us along the way. We have very similar ideas here with rational functions. And the first thing we said we're going to graph is our vertical asymptotes. And vertical asymptotes are when the denominator is 0. Okay, denominator d of x, which is our denominator, is equal to 0. Now what terms make this go to 0? If x was negative 2 and positive 2, take a look here. If x was negative 2 and x was positive 2, that would make the denominator go 0. And we're not allowed to divide by 0. And we said when we're dividing 1 divided by 0, that's what we call undefined. Fancy word, undefined. And undefined for us, we said, was pretty much us going to infinity. Why is it undefined? Because it's out of bounds. It shoots off to infinity. We're not allowed to play over there. So this we said was really the reason why for us, because this was going to go to infinity. And we don't know if it's plus or minus infinity. We just know it's going to be infinity. So let's go ahead and do that. So the first thing we're going to graph, I'm going to graph it over here, is at positive 2 and negative 2. We're going to give ourselves not a root, but a vertical asymptote. And I do this with dotted lines. And we've broken the graph into 1, 2, 3 parts. Okay, 3 parts. The next thing we said is that we want to find something called the horizontal asymptote. And what would this graph look like as we approach infinity? As we approach infinity, where would this graph get stuck at? And we said the way we had this, we have 3 different rules. 3 different rules. Is the top exponent, we said n and m, right? Is the for plus blah 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 plus blah blah blah, is the top exponent bigger? So is m greater than n? If m is greater than, if the bottom is bigger, that means our horizontal asymptote y is equal to 0. So if I say x squared over x cubed, let's do a plus 1 there so it's not perfectly going to cancel. We say our horizontal asymptote automatically is going to be 0. So y is equal to 0, I'm sorry. Y is equal to 0. What about if it's x squared over x to the 6? Well, the bottom is bigger. So again, our horizontal asymptote is y is equal to 0. What if it's x to the 5th over x to the 6? Just barely making it over. Yeah, horizontal asymptote, y is equal to 0. So as long as the bottom is bigger by any degree, we can say my horizontal asymptote is 0. And in this case, the bottom is bigger. Let's go take a look at it. The bottom is bigger, x squared versus nothing. Our denominator is bigger, so we're going to go towards 0. So I'm going to graph a horizontal asymptote. Let's use red here. and it's going to be at 0. So what does this automatically tell me? It tells me that the graph is going to become 0 eventually. I don't know if this is on top or on bottom. All I know is eventually this graph will go towards 0. So it could be any of these 4 possibilities here. But at least I have a framework. So these are the 2 main things we're going to graph. We're going to see these problems also have x-intercepts. Okay. Now, let me go ahead and give you rule number 2. Rule number 2 is what if x squared over x squared, let's say plus 1, what if this was the problem where the m and, so the n and m, oh, sorry, darn it, what am I doing? M and n were equal to each other. What if they had the same power, the same strength, you could say? Then we had our rule, we said it was going to be a1 divided by b1, meaning it's going to be the front on top and the front on bottom, and we just divide those numbers. In this example here, it's going to be 1 and 1. That's going to be 1 over 1 is 1. And that's my horizontal asymptote. Let me give you a couple examples here. What if I write 3x squared plus 1 over 5x squared plus 1? Are these the same strength? Yes. And what I mean by same strength is x squared is always going to be right next to x squared. So if I made x 10, 10 squared is 100. This would be 301 over 501. Isn't this pretty much like really close to 3 over 5? It's close. It'll never be exactly 3 over 5, but that's the idea. It's going to become closer and closer to 3 over 5 as these numbers get bigger. If x was 100, that means this would be 30,001 and 50,001. It's not even closer to 3 over 5. And what I'm talking about when I'm graphing this horizontal asymptote, the graph is 1, 2, 3. Okay, where's 3 over 5? 3 over 5 is like 0.6. We have a horizontal asymptote right here. And the graph would eventually become this 3 over 5. One of these pairs. Okay, so I don't know which one it is. We would have to plug in more values to guess. But at least I know this is where the graph would eventually tend toward. The last one we said, what if the top is bigger? What I mean by top is bigger, what if I say it's x to the 5th over x to the 4th? We end up with the top being bigger and this graph will shoot off to infinity. It's not going to be bounded by any horizontal asymptote. And we actually have a special rule. If the top is bigger by exactly 1, we have something called a slanted asymptote. Okay, we have something called a slanted asymptote. But we'll figure that out later. So we're going to use the skills that we just reviewed in today's assignment. And so our first question here, take a look here. F is a rational function given in the standard, in both standard and factored form. So we have our standard form on our left, meaning we didn't factor it. On our right, we factored it, broke it up to, we'll see the parts a lot easier. So use a point and draw line tools to graph the following. First, draw the points on the x-axis at the x-intercepts. So what's the x-intercepts? It's when the top of the problem goes to 0. Okay, what's 0 divided by any number? That's 0. 0 divided by 5 is 0. 0 divided by a million is 0. So can you guys look at the top portion here of this fraction and tell me what numbers would make the x minus 4 and the x plus 2 go to 0? X minus 4 is equal to 0. X plus 2 is equal to 0. Plus 4, minus 2, minus 2. X would be 4. X would be negative 2, right? So these are my two values that work. Okay, let's go ahead and graph those. So we're going to put a dot on 4 and a dot on 2. Oh, not 2, I'm sorry. Oops. A dot on 4 and a dot on negative 2. All right, those are the x-intercepts. Now, what's the next thing they want me to draw? Draw the vertical asymptotes. So we just reviewed, where are the vertical asymptotes going to be? Vertical asymptotes are when the denominator goes to 0. So what values would make the denominator go to 0? X minus 3 is equal to 0, and x plus 1 is equal to 0, plus 3, minus 1, x is 3 and x is negative 1. And of course we can do this mental math. 3 would make that go to 0 and negative 1 would make that go to 0. So when we do divide by 0, we end up going to infinity. And this is our vertical asymptote. Let's go ahead and draw vertical asymptotes. We said it was going to happen at 3. 2 dots, okay? 2 points, any points you want, doesn't matter. And over here at negative 1. Okay, positive 3 and negative 1. Our last one here is our horizontal asymptote line. Now, the problem writes this a little funny, more funny than we normally would. But we can say this is negative 2 times our horizontal asymptote, whatever that is. But if you want to multiply it out, this would have been negative 2x squared minus plus 4x plus 16 over x squared minus 2x minus 3. This is how normally you would see it. Now looking at the front, since these are the same speed, right? X squared, what do you think the horizontal asymptote is going to be? It's going to be negative 2 over 1. And that's our easy way of looking at it. If you want to keep it in this form, that's also fine. What is negative 2 times x squared over x squared? What happens? What's the horizontal asymptote for x squared and x squared? That's 1 over 1. That's negative 2 times, negative 2 times 1 is negative 2. So either you can keep this on the top because it's negative 2 over 1, or you could multiply it out. So my horizontal asymptote for this problem is going to be at negative 2. Okay, so we're going to take this framework and we're going to take that next step. What does this graph look like? Now, I'm going to ask you, does the graph go on top here or on bottom? On the right. Now, since we found the x-intercept already, that's an easy hint. Because for sure we're stuck on this part of the graph. That means we're going to be graphing from up here. As x gets bigger, we're going to get closer to negative 2. As x gets closer to 3, we're actually going to shoot off to infinity. So we're stuck in that corner. We mentioned before we can't draw a line, right? Because we're blocked off in both directions. So we're going to bend to our asymptotes. Okay, looking on my left side, the endpoints are end behavior is always the easiest. On the left side, do you see how we already have a dot here? That means for sure I'm going to be stuck on this side of the graph. I'm going to be stuck on this side of the graph. Why? If I was down here, I'm not going to come up and hit it. Now in the middle, that is one of the hardest parts. And we're going to have to plug in values. First thing, do we have any roots here? So for sure the graph isn't going to cross over my x-axis. So that's not going to happen. If anything, it might be up here. But most likely, 99% of the time, it's going to be down here. So how do we figure out, how do we tell where it's going to be? We'll just plug in a number. Pick a number, 0, 1, or 2. Any of these numbers are easy numbers that we can plug into the equation. Let's pick 0. If I plug in 0, that'll be 0 minus 4, 0 plus 2, 0 minus 3, and 0 plus 1. That's going to be negative 2 times negative 4 times 2 over negative 3 times 1. This gives us 8 times 2 is 16, positive 16 over negative 3. Take a look, this value is negative 5.33 because 3 goes into 16, 3 goes into 15 5 times, remainder 1/3. And where's negative 5 over 3? That's way over here. So we know we're going to be stuck something like this on the bottom. So the framework gives us a structure where we can graph around. Knowing the x-intercepts, the roots, helps us make a quick determination where are we stuck in the graph. Now to prove this to you, let's go ahead and show you something on Desmos real quick. Oh, go away, buddy. I think they want me to. Done, save. If I go to Desmos and I graph this function exactly. So in negative 2, then parentheses, x squared minus 2x minus 8 divide this by x squared minus 2x minus 3. And if you take a look at this graph looks very similar to the one that I had just drawn. Couple points. We said this was going to be a negative 5.33. Yep. We had a 0 at 4 and at 2. And we actually have horizontal asymptotes right here at negative 2. Let me graph that for you. Y is equal to negative 2. Oops, sorry, the negative didn't come out. Negative 2, right? That's my horizontal asymptote. And we said we have vertical asymptotes at, for this problem, we said it was going to be x equals to 3 and x equals to negative 1. And you can see that these asymptotes border my graph. They trap my graph. It's almost like a zoo. Upper right-hand corner, upper left-hand corner, and bottom middle. They give us a framework to graph our graphs around. Kind of like our sine graphs too, where we drew the dots first. Okay, let's do another problem. And let's go ahead and submit question. Yep, I got that one right. Yay. Now let's do the same thing for the next problem. My point is that these problems, when they're factored, when we're looking at the asymptotes, the vertical and horizontal, become super easy problems to graph. We don't have to worry about all the decimals in between. We just worry about our key points, our vertical asymptotes, and horizontal asymptotes. So here we go. For this problem, what are my zeros? My x-intercepts are when the top goes to 0. That's going to go 0 at 0, at 2, and negative 2. Easy peasy. 2, negative 2. Got those down. What are my vertical asymptotes? Vertical asymptotes are when the denominator goes to 0. At 3 and negative 3. At 3, negative 3. And then we have, what's my horizontal asymptote? Looking here at the front, that's going to be a 1. So it's going to be 3 times 1. Or you can write this as 3x squared minus 12, that's 12, over x squared minus 9. You can see that they're the same speed, so it's 3 over 1 up here. Okay, so let's go ahead and graph this onto our homework. Homework says go ahead and graph our x-intercepts. We said x-intercept is going to be 2 and negative 2. Vertical asymptotes at 3 and negative 3. Man, how'd you do it so fast? It's because we're just looking at the factored points on top. Horizontal asymptote, we said it was going to be positive 3. And now we have a guideline for what the graph will look like. Now, if I take the next step and say, hey, go ahead and graph the graph, well, I want you to notice that this has to be stuck this way. Why? Because the graph isn't going to come on from the top and cross that horizontal asymptote in this way. We're going to be stuck in this point. Also, just if you want to double check, you see how 0 is here? Let's plug in 0. If I plug in 0, 0, 0, 0, that's 3 times negative 2 times 2 over negative 3 times 3. That's 12, negative 12 over negative 9. It's 1 point something, 1.3. Okay, so 1.3. So it's actually going to be like right here. So now I have 3 points on my graph. We know to go ahead in this direction. What does it look like on the right? Is it going to be up here or down here? I don't know. So how do we figure out, how do we find the rest of the points? You plug in a number. So let's go ahead and plug in a number. Pick a point on the right side. Let's pick a 4. Pick 4. So I plug in 4. 3 times 4 minus 2 is 2. 4 plus 2 is 6. On the bottom, 4 minus 3 is 1. 4 plus 3 is 7. And this is 6 times 6 is 36 over 7, which is approximately 5.5 and 1/7. This is bigger than 5, right? So isn't 5 way up here? So the graph we know for sure is going to be stuck up here. 100% guarantee you that. On the left side, if I plug in negative 4, 3, negative 4, negative 2 is negative 6. Negative 4 plus 2 is negative 2. Negative 4 minus 3 is negative 7. Negative 4 plus 3 is negative 1. So we have positive 36 over positive 7. So we have the same 5 to the 1/7, which is up here. 5 to 1/7 is up here. So we know we're going to be stuck on top here. I can guarantee you that's what the graph looks like. We only plugged in 3 points. That's the only work we actually did here. Yeah, that's really the only work we did here. Okay, so I'm going to go ahead and make sure you guys believe that. This was our graph. Oops, wrong one, I'm sorry. Okay, so our problem was, I'm going to try to rewrite this. Let's say it's going to be 3x squared minus 12, we said, on top. Divide that by x squared minus 9. Now if you take a look at the graph that we drew, at 4, we said 4, we're going to be at, let's see, 4 is 5.14, I guess that's 5 1/7 on my right. On the middle we said 1.33, like we declared, yeah, 1.3. On my left at negative 4. Something like 5.17, whatever again. Okay, so the graph on my right looks just like the graph on my left, except how much work did I really do? I only graphed 2 points, in this case 3, because I also included the y-intercept. Okay. So this is the guideline for us graphing these rational functions. We graph horizontal asymptotes, we graph vertical asymptotes, and we're good to go. Okay. Uh-oh. That's not it. Okay, there it is. Alright, submit. Okay, winner, chicken dinner. And you're going to do this for the next couple of questions. Just follow what those rules are saying. First, find the x-intercepts, then find the vertical asymptotes, then the horizontal asymptotes, and then you have your framework for the graph. This assignment here is not going to ask you to graph the rest of the graph, but you come up with that framework, and that's the hardest part, I think. Right, so you have a couple questions on this. Over here, this one's going to be graphing the actual graph. And the next set of problems are going to be somewhat pretty easy, but we're going to look at some characteristics first. Let's look for our horizontal asymptote first and our vertical asymptote. So horizontal asymptote, so vertical asymptote first is when the denominator equals to 0. When does the denominator go to 0? It goes to 0 at 2x minus 2 is equal to 0 when x equals to 1, right? 2 times 1 is 2, 2 minus 2 is 0. Okay, vertical asymptote, done. Horizontal asymptote, 4x plus 2 is 0. Minus 2, then divide by 4, x equals to negative 2 over 4. That's negative 1/2. Okay? So at negative 1/2, here's my horizontal asymptote right here, negative 1/2. Now for this problem, they also want you to plot an actual point. Because now that we have the horizontal asymptote and vertical asymptote, we don't know, is the graph up here, down here, this way, or this way? We don't know. So we're going to pick a point. And in this case, let's pick 0. See how 0 is a nice point always to graph, if possible. Let's plug in 0. If I plug in 0 and 0 to the problem, we end up with, if I plug in 0 and 0, we end up with 2 over negative 2, which is negative 1. So for sure, my graph is graphed here at negative 1. That means we're going to be stuck in this corner here. On the right side, we can plug in 2. Let's go and plug in 2. 2 times 4 is 8. 8 plus 2 over 2 times 2 is 4. 4 minus 2. That's 10 over 2 is 5. So at 2, we're going to be at 5 up here. So we're looking at the graph that's going to be in this corner here. Let's go ahead and graph that. So the rule says place the horizontal and vertical asymptote. First we said it was going to be at 1, negative 1/2, I think. Oh, it's positive 1. Did I say? Whoops, positive 1, right? My bad. Oh, that's right. Okay, 1, yeah. My x is 1 and my y is negative 1/2. And then we have to pick one point now. Now the thing is, depending where I put this point, depends how I shape the graph. And when we said when we plugged in 0, we end up with negative 1, I will put the graph right there. Is that right? Wait, If I plugged in 0, if x is 0, negative 1. But what if I plug in 2? If I plug in 2, let me check 2 again. I think I messed up on 2. If I plug in 2, 2 times 2 is 8. 8 plus 2. Okay, because look, 2 looks like it's going to be a 0 here, doesn't it? Oh. Whoops, I misgraphed it. This guy here is at 0. It's, what do we say? 0 is going to be negative 1. Oh yeah, no, that seems right. 0 is negative 1. If x is 0, y is negative 1. Is there a horizontal? Oh my goodness, what's my horizontal asymptote? Oh my gosh, I'm such an idiot. Oh my gosh, what am I doing? I don't know what I'm doing. When I was doing horizontal asymptote, I don't know what I was doing. But the horizontal asymptote here is 4x over 2x, right? The same speed. The horizontal asymptote is 2. How did I even get 1/2? What was I doing? Another screw up. I screwed up in the other class too. Like, I don't even know what I was thinking about. Okay, so my horizontal asymptote is actually up here at 2. Oh my goodness. Okay, let's redraw this. My horizontal asymptote is at 2. My vertical asymptote is at 1. And my point we said was at 0 is going to be negative 1. And if you look here, on the right, 2, when x is 2, it should have been up here at 5. Okay, that looks terrible. But okay, draw it again. This one's tough because you have to draw the horizontal and vertical asymptote at the same time. And then you pick a point, and we said it's going to be 0, negative 1. Okay, done. Okay, let's do another question like this. Let's do a similar question. The similar question looks so similar that it's practically the same problem. Vertical asymptote is make the bottom go to 0. That's going to be negative 1. Or horizontal asymptote, negative 4x over 2x is negative 2. If we plug a point, that's plugging 0. If I plug in 0, we end up with 1. 0, 0, we end up with 2 over 2. That's just 1. Let's use these characteristics to draw my graph. Negative 1, we said negative 2. Whoops. Negative 1, negative 2. We also said we had a point when I plugged in 0, we end up with 1. Right, that's it. The last part of this problem for your homework, you only have 12 questions today for your homework, is this here. Find which graph does match the problem given. Okay, which graph matches the problem given? And a couple of characteristics are given in each of these graphs. The roots are given, and the horizontal asymptote, and the, well, kind of horizontal asymptote, but then the vertical asymptotes for sure. So these are my roots. That's my y-intercept. And then we have our vertical asymptotes. Okay, these are the characteristics that are given in this graph. Now, I want you guys to take a look here. Let's come up with our own set of vertical asymptotes and horizontal asymptotes and roots. So for this problem, look at the roots. The roots would be at 1 and 2. Negative 1 and 2. You guys go, oh, darn it. Negative 1 and 2. Why? Because that's what would make this go to 0. negative 1 plus 1 is 0. 2 minus 2 is 0. What's my vertical asymptotes? When will the denominator go 0? When x is negative 3 and 4. So looking at my first problem, we do have our roots at negative 1 and 2, and we do have our vertical asymptotes at 3 and 4. This looks like the graph, and it might be it. I don't know. Horizontal asymptote, it's going to be 2. It's 1 and 1 because it's x squared with a 2 in the front. That's 1 times 2. 2. And that does look like 2 to me. Now, the next thing I want to just make sure is, remember we said we can plug in 0 because 0 is a value we can check. What does the graph look like? If I plug in 0, 0, 0, 0, 2 times 1 times negative 2 over 3 times negative 4. This gives us negative 4 over negative 12. Is that going to be positive or negative? Negative 4 over negative 12 is a positive 1/3. And that looks like 1/3 to me on top. Now, let's look at which ones don't work. If you look at the second choice here, yes, the asymptotes, the vertical asymptotes, my answer was right here, negative 3. But if you look at the second graph, it's actually negative 4, which is not what we wanted. And the roots are wrong. The roots we said was negative 1 and 2. This is negative 2 and 1. Let's look at the third option, negative 3 and negative 4. Yep, that was it. We had roots at negative 1 and negative 2, but the y-intercept, take a look here, that y-intercept is at negative 1/3 when we said it was going to be positive 1/3. That's why it's not going to be the third equation. And the fourth one, same thing, the vertical asymptotes are wrong. Negative 4 and 3, nope, we said it was negative 3 and positive 4. So our choice is only the first one. Right? All right, let's do a similar question. Let's do one more. So I want us to take a look at what are the vertical asymptotes for this problem. So what are vertical asymptotes? What would make the problem go to 0? Negative 5 and 3. Now, are the vertical asymptotes here negative 5 and 3? Nope. So we know the first one isn't the right answer already. Automatically, you can tell. What are the horizontal asymptotes? We said it was going to be 2x squared over x squared, right? X times x is x squared with a 2 in the front. So we see this is going to be 2. Okay, 2 looks good. And then what are the roots? The roots are negative 3 and 1. Negative 3 and 1? Nope, the roots are not negative 3 and 1. So we have these characteristics that we could probably, we're drawing here. That's what the graph should look like. Negative 3 and 1. So let's find the graph that matches these characteristics. Roots of negative 3 and 1. First choice, negative 3 and 1. Take a look. Nope, that's negative 1 and 3. Second choice, negative 3 and 1. Nope, that's negative 1 and 3. Third choice, negative 3 and 1. Yes. Do we have the correct vertical asymptotes? The vertical asymptotes we said was 3 and negative 5. Let's take a look. 3 and negative 5, yes. The bottoms would be at 3 and negative 5. But what's my horizontal asymptote? My horizontal asymptote is at positive 2. And our choice for number 3 here, it is not positive 2. It would have been at negative 2. See, they're thinking horizontal asymptote is negative 2 here, which is not what we wanted. Let's look at our last choice. Let's see if it fits everything we want. All the characteristics we want to find in a mate. Oops. That was this one here, I think, yep. We said horizontal asymptote at 2, yep. Vertical asymptote is negative 5 and 3, yep. We have zeros at negative 3 and 0. So negative 3 and 1, I'm sorry. And if I plugged in my 0, we would probably end up with a positive. All right, that's it.